Okay, let's talk about some new Java statements. I want to talk about how we're going to get the computer to repeat actions over and over again. So far, our programs have started in main and then gone through. Maybe they jump up to a method, but they go through the method. Sometimes they take a little detour with an if statement, but we want to be able to repeat things over and over because that's what good computers are good at. So one form of this is called a while loop. So we want to, in this video, understand the syntax of while loops. We want to know how the computer interprets the while loop. In other words, what are the steps it does to do actions based on the while loop, and then to see some situations where a while loop can be used. So a while loop repeats a block of code while some expression is true. And of course, if we're seeing if an expression is true, that means it's going to be some kind of Boolean expression, like we use in the test for an if statement. So I think learning about if statements and learning about while loops are very well connected. If you're good at one, the other one is pretty straightforward. So the syntax of the while loop is the keyword while. Then inside parentheses is the Boolean expression. And then there is a code block with some statements inside it. And the way you evaluate the while loop is, let me draw for a second here, is you test the Boolean expression. So if that's something like, number less than 5 or something like that, it checks to see whether that is true or false. If it's true, it does whatever statements are there. Once the statements are finished, it comes up again and checks the Boolean expression. If that's true, it does the statements again. But if it's false, it jumps down to the next line of code after the code block. So basically it loops repeating while the Boolean expression is true. And as soon as it's not true, it skips over those statements and continues the rest of the program. Now, one thing that I want you to notice is that it only checks the Boolean expression when it's done, at the very beginning, and then before it starts the next iteration, the next loop of the while statement. If the statements cause the Boolean expression to be false, it's not like it keeps testing it every little second of the loop. It only checks the Boolean expression after it's done with the statements, and it comes back up, and then it checks it. So again, it's not like another thing looking at the value of that Boolean expression, deciding whether immediately when it turns false. It waits until the statement block is done, and it loops up again to finish the loop. All right, so we'll see how that works in just a moment. Yeah, so it keeps going until it's false. So let's write a loop. I'm going to write it in main, I guess, here. So I'm going to make a variable int counter equals 1. So again, I'm declaring an integer variable counter and assigning 1 to it to initialize it. And I'm saying while, and then inside parentheses, and notice Eclipse again is sort of, when I start the parentheses, it makes the close parentheses for me. Counter less than 11, and then a code block that's indented, and I'm going to do some kind of action. I'm going to print out counter, and I'm going to add 1 to counter. All right, so let's run it, I guess. So this was from the last lecture, the results 15. It starts off at 1, and then it counts up to 10. Now, the only tricky thing really with while loops is deciding when it's done. Like, what's the last thing that's going to print out? Because, like, for example, there's this number 11 here, but it didn't print out. And why is that true? Well, let's make this a little bit smaller so we can kind of get to it a little bit faster. 1 less than 3. Print it out. It prints out 1 and 2. So why is that? Well, again, here it's worth writing on paper and tracking the execution of the program as it runs. So let's do that. All right, so counter, I'm just going to, counter is 1. Boy, that's not a very good, I'm kind of writing in like vertically here a little bit. It's a little bit hard. Okay, what's the while loop do? It tests the condition. Is 1 less than 3? That is true. I'm just going to write some true falses over here. T for true. Since it's true, it executes the code block, the statement block. It prints out counter. Okay, here's my output. Print out 1. Just as bad as before. And then what does this do? It assigns a new value to counter, which is the old value plus 1. So this turns into 2. Then it gets put in counter. I'm going to put a 2 here. We test. It's 2 less than 3. That's true. Print out counter, 2. Add 1 to counter. The old 2, right, is now 3. Gets put in counter. Is 3 less than 3? Somehow, that's not hard to answer, but somehow when you say it out loud, it just sounds so ridiculous that I think my brain at least sort of pauses for a minute, right? Is 3 less than 3? No, it's false, right? Because it's false, we skip over the statement block, go to any remaining lines. There are no more remaining lines, so the program is over. So notice, we started at 1, and we went up to, but not including that value, right? We stopped as soon as we got to 3. So it didn't print out 3. And again, this expression here could be complicated, right? While counter less than 3 and ampersand ampersand number of people equals 5, or anyway, you can kind of string together a bunch of stuff there, so you can get fairly complicated. But again, it's important to force yourself to write these things down very methodically. If you're trying to figure out why your program's not working, you need to go through this process of doing these things and I didn't mean to do that. Okay, of doing these things and checking to see if what you think the program is doing is confirmed by print statements and so on. All right, so something has to change each time in the loop, right? The idea of the loop is to make some progress towards some sort of answer. So here we have the counter equals counter plus 1. I'm showing here a different form. This is called the increment operator, and it basically takes this variable and adds 1 to it. All right. It takes a little while to get used to seeing that. Like, it just seems like it's just sitting there, but it has the advantage of not being able to make a mistake in some ways, right? So if I say counter equals counter plus 1, what if I said counter 2 equals counter plus 1 and made a typo kind of thing? Here, it only applies that one variable name and it adds 1. So there's sort of just, you know what it does, right? That's called the increment, and you'll see a lot of that. What happens if we don't have that in there? So I'm just going to comment it out. In other words, that it's not going to be executed. So here, start at 1, go while it's less than 3, print out counter, and repeat. It is what's called an infinite loop. It doesn't stop. There are some uses for infinite loops sometimes, because maybe there's a different way to quit out of the loop, we'll see. But for the most part, infinite loops are dangerous. And for example, if you submit an infinite loop to Gradescope, it's going to run a long time, and then we have a timer set, so after some amount of time it quits. But you won't get any results back is one thing if you have an infinite loop. So I can't do anything because it's still running the program, right? In fact, my fan is heating up because it's working hard printing out 1s, and I'm going to this terminates stops the running program. So this is a useful thing to know for sure. And in fact, sometimes if you just have a blank, maybe I didn't have the print line, then it would just be like a blank thing, and you're like, I don't know what's going on here. You have to notice that, oh, it still must be running because I'm allowed to terminate it. So I'm going to terminate it, then it gets back to normal over here. So there's a lot, you can pay attention. There's a lot of little things to pay attention to when you're running and debugging, fixing your programs. And that's one of the things to look for. Is it still running, or did it actually finish? And sometimes you need to just add some print statements, because then all of a sudden you see like, hey, this is showing up over and over again, and then you realize, okay, there's something wrong here. So yeah, without the increment, without the progress in the loop, it goes forever. Now, here we had an int variable and a relational operator checking, comparing the variable to some number. That's not the only form we can have here, right? We could have call a method while the game is not over to your next turn. Right? This is a pretty common setup. It's called the game loop. And next turn actually, oh, didn't mean to go there. And the next turn might, update the display, update the position of characters in the game, that kind of stuff. This method here, I'm calling a method that returns a value. Because it's being used in a while loop, this thing, when you look at it, you realize it must return a true or false value, right? Because it's trying to compute some true or false thing to decide whether or not the loop continues. So we can use methods, for example, in the while loop. While loops are useful where maybe, here I'm basically counting up 1, 2, 3, 1, 2 kind of thing, pretty predictable. But here, I'm starting at some value, and each time I am multiplying it up by some scaling factor. So this actually makes an exponential curve if you look at the values over time. I keep tapping this thing, and I don't know how many times I want to loop. It's not like I want to loop 10 times. It's not like I want to loop 5 times. I want to stop when this value gets too big. So I want to continue while the value is less than some number. And so this is a way to kind of go until something happens, right? That doesn't mean go 10 times, and it's not going to mean 100 times. It means go until something happens. And in this case, it's when I hit this value. And so again, I don't want to have to know in advance to go 10 times or 128 times or whatever it's going to be. I just want to say, let me know when I've earned $1 million or something like that, right? And then it will stop. So while loops are good for this kind of indeterminate looping, when you don't know the number of times it's going to loop, but you know why you want to continue looping and why you want to stop. All right, so while loops show up a lot. They're very, very useful, cool thing.